308.4 miles per hour. Faster than a jet on the runway. In the next 60 seconds, you'll see how the Yangwang U9 Xtreme reached that number, the clever trick that made it possible, how the Yangwang U9 Xtreme became the fastest car. Think of this as a tidy engine room tour. The Yangwang U9 Xtreme didn't win the top speed headline by luck. It's a focused package of hardware, software, and setup designed specifically to erase the limits that hold most cars back. Below, I walk through the features that mattered most: the motors, the electrical platform, the battery, cooling, aerodynamics, tires, chassis and controls, and explain how each one pushed the U9 Xtreme toward that record run. The U9 Xtreme uses 4 high-performance electric motors, one per wheel, tuned to produce astonishing peak power. Those motors aren't tuned for short bursts only, they're built to deliver sustained kilowatts. More motors mean the car can split the work across 4 units, lowering stress on each motor and enabling higher total output without a single component overheating immediately. Independent motors also allow aggressive torque vectoring, which helps stability under extreme acceleration at high speed. The headline horsepower numbers are extreme by design, but what matters more is the motor's ability to maintain that output. Yangwang's motor engineering focused on higher rotational speeds, improved cooling passages inside the motor housings, and reduced electrical losses through refined winding and magnetic materials. The result? Motors that can spin hard, push huge current, and keep doing it without thermal collapse. Most EVs operate at 400 volts or 800 volts. The U9 Xtreme moves to a 1200 volts architecture, and that shift has real, measurable benefits. Higher voltage lets the car transmit the same power with lower current. Lower current reduces I2R losses in wiring and electronics and eases the thermal burden on inverters and connectors. That creates a system that's lighter, more efficient under extreme load, and less likely to throttle power because of overheating. A 1200 volts platform also enables more compact power electronics and faster response in high-power situations. For a top-speed run where you need steady maximum output for tens of seconds, those electrical advantages are decisive. The U9 Xtreme pairs its high-voltage system with a battery pack designed for rapid, sustained discharge. This isn't the same pack tuned for range, it's a performance-focused layout with cells and cooling engineered to tolerate high C rates. The chemistry emphasizes thermal stability during heavy draw, minimizing voltage sag while maintaining cell integrity. Cell packaging, bus bar layout, and internal cooling channels were optimized to keep temperature gradients small across the pack. That matters because uneven heating causes early power cutbacks. Yangwang's design keeps the pack healthy through repeated high-power runs, allowing the motors to remain at peak output long enough to climb past the previous top speed thresholds. Heat is the silent limiter for extreme EV performance. Yangwang invested heavily in thermal systems for batteries, motors, and inverters. The car uses multiple dedicated cooling loops and large heat exchangers sized specifically for high-speed, high-power runs. Liquid cooling paths are short and targeted, and the vehicle uses active thermal control to bias cooling where it's needed most during a run. These solutions let the U9 Xtreme sustain maximum power without hitting thermal protection limits. The 1200 volt system reduces heat generation at the electrical level. The mechanical cooling systems remove what's left, and the overall result is steady, usable power instead of early. Protective shutdowns. At 300 plus pH, aerodynamics isn't an accessory, it's the primary opposing force. Yangwang optimized the U9 Xtreme's body for extremely low drag while managing lift. The car combines a long, low nose, tight underbody management, and subtle aero elements that produce stability without the large drag penalty of big wings. Underbody airflow control and diffusers move air smoothly away from the rear, reducing turbulence that can unsettle the car at top speed. Small generating surfaces add downforce where necessary, but are tuned not to significantly increase drag. The balance between minimal drag and sufficient stability is where the U9 Xtreme's aero package really shows discipline. Next comes tires. Tires become critical components at extreme speed. The U9 Xtreme used specially developed high-speed tires rated for sustained runs near 500 km per hour. Those tires are reinforced in the bead and sidewall areas to resist deformation, and their compounds are chosen chosen to tolerate high rolling temperatures without rapid degradation. Tire pressures, load distribution, and wheel alignment are set with the top speed envelope in mind. Those settings reduce the risk of unwanted flex or heat buildup that could trigger instability or catastrophic failure during a run. Along with all this, the structural rigidity matters because any flex becomes amplified at speed. The U9 Xtreme chassis is stiffened and tuned, so the suspension can work predictably. Dampers, anti-roll bars, and spring rates were selected to keep the car settled in a straight line at high velocity while still tolerating small surface variations. The suspension geometry avoids wheel lift or toe changes under aerodynamic load. That predictability reduces the chance of sudden, hard-to-correct behavior at top speed and lets driver inputs remain minute and precise. Electronics tie everything together. The U9 Xtreme's control systems manage power delivery, torque distribution, traction control, and stability in real time. Torque vectoring uses the 4 motors to micro-adjust torque at each wheel, helping keep the car neutral and stable while accelerating through the speed range. Control software also prevents abrupt interventions that would interrupt a clean top-speed run while still protecting the car from unsafe conditions. For the record attempt, the engineers calibrate those systems to be as permissive as safety allows, trading off aggressive output for predictable, recoverable behavior. Exterior design and details. The Yangwang U9 Xtreme's exterior is all about purpose, wrapped in a clean, confident shape. At first glance, it looks like a hypercar, but everything has a job: reduce drag, control airflow, cool critical systems, and keep the car stable at extreme speed. The surfaces are low and long, the nose is slim, and the profile stretches backward to let air flow without turbulence. Those proportions aren't for looks alone. They shave off drag and delay separation, so the car needs less power to push through the air. The front end is minimal but precise. A narrow intake area limits the frontal opening while channeling air where it's needed. Brake ducts, radiators, and battery coolers. You won't find big gaping grills. Instead, there are sculpted air channels and hidden vents that feed cooling circuits without creating extra drag. The headlights are slim and integrated so they don't disturb airflow, and the lower splitter is subtle, tuned to create the right amount of pressure under the car without adding excessive drag. From the side, the U9 Xtreme's wheel arches are shaped to reduce turbulence around the rotating tires. The doors and side sills are cut to manage boundary layer airflow and feed the underbody ducts. The roofline slopes gently into a long tail, and a small cabin area helps lower the frontal area. Mirrors are compact and aerodynamically profiled. Where possible, the design uses camera mirrors or recessed housings to minimize drag. Every curve around the greenhouse helps the car slice through the air rather than fight it. The underbody and diffuser do much of the heavy lifting. A smooth undertray guides air cleanly rearward and prevents the chaotic flow that produces lift. The diffuser expands that airflow in a controlled way to lower pressure under the car, creating stability without a massive wing. Rear aero elements are deliberate and restrained. Small fins and an integrated deck that produces downforce only where it's effective, avoiding unnecessary drag penalties. The result is a car that stays glued when approaching 500 km per hour, but doesn't pay the price in top-speed robbing drag. Materials and finish reflect the car's two tasks: strength and lightness. The body uses a mix of carbon composite panels and high-strength alloys, where stiffness matters. Panels are tight, gaps are small, and the build quality reduces parasitic air loss. Paint choices and surface textures are selected with airflow in mind. Even the seam edges are smoothed to avoid tiny vortices that matter at extreme speed. Cooling outlets are integrated into the styling rather than slapped on. You'll see flush vents on the flanks and rear that open when needed and close when they're not. That active behavior keeps the car tidy at cruising or road use while allowing extra airflow during record attempts. Brake cooling ducts are channeled through the bodywork so they don't disturb the main flow, and the rear houses large controlled outlets to let hot air exit cleanly. Wheel and tire packages are part of the external engineering. Wheels are shaped to reduce drag and help vent air from brakes. Tire bulge is contained by the arch design. and rims are tuned to avoid creating additional turbulence at the contact patch. Interior design and details. The U9 Xtreme's interior is built around a single idea: let the driver focus on speed without distraction. It isn't trying to be a lounge, it's a precision cockpit where every surface, control, and display exists to support control, feedback, and concentration at very high speeds. The seating position is low and slightly reclined to lower the center of gravity and give the driver a direct feel for the car's movements. That posture makes subtle steering inputs more effective and helps keep the body stable under heavy acceleration. The steering wheel is compact, chunky, and shaped for a firm, reliable grip. Primary controls are where your thumbs and fingers naturally rest, and most buttons are physical and tactile rather than hidden behind menus. That design choice cuts the time it takes to make adjustments when milliseconds matter and the speed needle is climbing fast. The instrument cluster is deliberately minimalist. A clear central digital pod shows speed, motor output, temperature readouts, and a simple torque distribution graphic. Secondary screens exist for deeper diagnostics, but they're placed so they don't pull the driver's eyes away during a run. Materials mix track-focused function with enough refinement to remain comfortable. Carbon fiber structure and exposed metal are used where stiffness and lightness matter, while contact surfaces get high-grip materials like Alcantara or textured leather to prevent slipping under heavy G-forces. Seats are race-style and highly supportive, shaped to clamp the pelvis and shoulders so the driver doesn't shift. This keeps muscle memory accurate and steering input precise. Seat adjustability focuses on repeatability rather than complexity, so you can quickly restore the exact driving position you prefer. Controls are designed to be used by feel. Shift paddles and primary toggles have distinct textures, so they can be operated without looking. Drive mode selectors are robust and intentionally simple, so you can switch the car's behavior between road use and performance settings without navigating menus. Infotainment and climate functions exist for daily usability, but they're intentionally de-emphasized during performance driving. They're reachable but not intrusive. Haptic feedback is subtle and informative. If a stability system intervenes, it gives a quick, intelligible cue rather than a startling jolt, communicating the car's state without surprise. Visibility is balanced for both aerodynamics and situational awareness. The windshield is shaped to reduce drag, but still provides enough forward view to pick a line at high speed. Mirrors are slim and positioned for quick glances. Optional camera mirrors further reduce drag while preserving awareness. Sound insulation is tuned so cabin noise is manageable without deadening useful mechanical or tire cues. You still hear enough of the drivetrain and road to sense changing conditions, which is valuable feedback at extreme speed. Passenger accommodations are sporty and restrained. The space is comfortable but purposeful, with minimal storage and fewer distractions. Infotainment for passengers can be muted or locked out during record attempts to keep the cockpit focused. Safety features are integrated visibly but without clutter. Strong seat mounts, options for multi-point harnesses, accessible fire suppression points for track configurations, and visible roll structure where it contributes to stiffness and protection. This cabin is built for one purpose: control at extreme speed. Everything inside is deliberate, repeatable, and stripped of distractions. Sit in it, and the U9 Xtreme hands you the tools to push limits and stay in command.